Hello, welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're joining us on Zoom, just look at the top of the bottom of your screen. Wherever your Zoom controls are, you should see a little Q&A button. Click that button, hit submit, and I'll get to those questions at the end of the session. If you're joining us on YouTube, just use the live chat function. Wherever it happens to be on your screen, type in your questions, and I'll get to those at the end of the session as well. So my name is Jason Gabrinas. I'm one of Snap-on's national diagnostic technical trainers. Been in the training department the last 9 years or so, traveling around North America, helping Texan shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snap-on. Had about 30 different Snap-on franchisees I worked with, as well as the shops that they serviced in order to help everyone get the most out of their diagnostic needs. Then before that, it was 8 years at Subaru. So worked in a dealership, and over time, I guess, just became the diag guy in the shops. Always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bay. And before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So today we are talking about advanced lighting systems. So we're going to stick mainly to the headlights, because we've seen headlight technology has really changed just in the last maybe 10 years, if that. There's been a lot of changes really rapidly in the last few years, especially with all the ADAS on vehicles. It's related to that as well. So we're going to talk about a few things. We'll talk about the history of the headlight. Really don't have to go back all that far. But we want to talk about where these different technologies came into play throughout the years. And you'll see it was pretty much the same for the Model T up until maybe the 80s or 90s. Then it started going a little, going all over the place. So talk about projection lighting. Can use different types of bulbs with that, but that's still fairly common out there. HID lights, LED lights, which are a newer technology, and then all the intelligent lighting that goes along with it too. We're making lights move around corners and things of that nature. So we'll talk about the different things, a couple tips and techniques through that, and how we might go about diagnosing some issues on these, because they do have codes now, which makes life a little bit easier sometimes, but it's some crazy technology out there. So I'm going to stick to the US because that makes it simple enough. But in the US, 2 circular headlights, well, that was the standard. They standardized it in the law, in the regulations, beginning in 1940. And there were that sealed beam round bulb that you would always see, just like this one down here. In the late 50s, they started allowing 4 lights. So then we had high beams and low beams in the late 50s. 1974, regulators began allowing rectangular sealed beam lamps. So if you remember, like the Ford vans back then, the 80s, they were square. And then in 1983, finally, the regulations were changed to allow replaceable bulb, more aerodynamic type headlamps. So manufacturers started making them a little bit more curvy, a little more aerodynamic. We can replace the bulb in the back and just have a plastic housing with a reflector and so on and so forth. So they finally, back in 1983, allowed that. Throughout the 80s, the manufacturers began using those more aerodynamic designs, and then projector lamps came on the scene. So projector lamps began in 1986 with the BMW 7 Series, was the first mass market vehicle that had those projector style lamps in there. Now, there's many vehicles nowadays that use those still. Many vehicles that use some other different styles we'll talk about as well. So that gets us through the 80s. During the 90s, manufacturers started developing HID lights. So that stands for high intensity discharge lights. They're high voltage, and they use salts to create a very bright, very white light. The first mass market HID lamps were in the 1992 BMW 7 Series. There's that 7 Series again. Seems like BMW is always trying to move that lighting system forward on those, I guess. The first full 4-bulb HID system, so high beams and low beams, 1999 Mercedes CL class. So that was the end of the 90s. Then started taking off with the LEDs. So starting in 2004, the manufacturers began developing those LED headlamps that we still see nowadays. They've been getting continually better. They've been getting continually brighter. So now a lot of times that's all you see going down the road there is those LED lights. So first mass market LED lamps from the 2006 Lexus LS600. And then the first full LED system that had high beams, low beams, all of that, all with LEDs, was in the 2009 Cadillac Escalade. That was in North America. Over in Europe, they had them a little bit earlier. But the very first true all LED headlamp system, 2009. So that wasn't that long ago, what, 13 years ago now? It's kind of long ago, but yeah, about 13 years ago, they first started using full LEDs. And that brings us kind of to today. We'll talk about a few more modern things like laser lights here in a minute. But let's dive a little bit deeper into detail on, say, like the projector lamp. So projector lamp uses a reflector that it would normally use with any of our other headlights, but then it reflects it through a lens. And then on this lens, we have this shield that can go in between, and you might have a solenoid to actuate that, and they'll give you your high beams and your low beams, because there can be separate. You'll have a separate high beam, separate low beams, or you'll have it all in one bulb or all in one projector unit housing, and then it just kind of goes up and down depending on where they want the beam to be, high beam or low beam. So they can be used with halogen or HID bulbs. They're used either way. You can use just a regular halogen bulb or the newer HIDs. They use a reflector and a lens that gives a beam a sharp cutoff too. You'll notice on projector beam lights that they have a pretty sharp cutoff down the road. Combo low and high beams use that shield, like we said, to change the light pattern. So here's a little bit more detail on that shield there. So we have our bulb here in the back. We have our projector lens on the front. And then we have our little shield that can be moved, kind of pivots up and down. So if it's down, we get the full spread of the beam. We get our high beam. And then if it's up, it cuts off part of the beam. And that gets our low beam. And we get more of that cutoff down there. So we can check the solenoids on these. We can actuate them on and off. We can check to make sure they're working, power and ground. So here's just an example of what the light would look like. So we get the bulb and it reflects around inside the reflector. But all of this down here, this reflecting gets cut off. So we get the low beam. And then when it's open, it allows it to pass through with the shield down. And it allows it to pass all the way through with the light open, shield rotated down. So we get our full high beam that way. So like I said, could be either a halogen or an HID in here. Just depends on what the manufacturer decides. So speaking of HIDs, we have our bulb here, and then we have what we call a ballast. We'll talk more about that in a little bit. But notice the caption here: do not open, will shock, burn, or cause death. You want to be very careful on the output side, the business end of these. Really, when you're testing these, you want to be testing on the input side, so 12-volt side, just to make sure it's working that way. Because otherwise, you're dealing with high wattage, high voltage there, and you don't want to get in. So HID lamps use a high voltage arc to ignite it. Kind of works with the same principle as a spark plug. So in order to ignite our air fuel mixture with a spark plug, we need tens of thousands of volts to cross and generate an arc. In order to generate that much voltage, you need an AC ballast. These don't run on DC, these run on AC, and an igniter to supply the proper voltage. There also can be commonly referred to as xenon headlamps because they use xenon gas inside the tube, and that's what allows it to start the arc. And then the bulb itself will have 3 different phases that it's going to run. It's going to run the ignition phase, which is first, then the initial phase, which is kind of a warm-up, and then a continuous phase once it's fully lit and the arc is continually self-sustaining. We call that the continuous phase. So in the ignition phase, a high voltage pulse, 10, 20,000 volts, ionizes that xenon gas, which allows it to have a channel to pass through, lowers the resistance, and then the current will start to flow, which lights it up, heats it up. In the initial phase, it's still being driven at high power, which causes the temperature inside the bulb to rise rapidly. And inside that bulb, there's some metallic salts, and that they start to vaporize, and that's what stabilizes the arc, creates a plasma, and then that's what generates the light for the bulb. Once it's gotten to that point, once the arc is stable, the computer can tell because of the way the resistance is reacting. The ballast will then supply a stable power, They have different ratings on the bulbs. So D1 and D2 bulbs, they'll run at 85 volts AC. And then on D3 and D4 bulbs, they run at 42 volts AC continuous. So those are, you got to worry a little bit more about the high voltage on those, but you're testing the input and the ground, and there's still relays involved usually. But oftentimes we also get a computer controller. So this is where it starts getting a little more complicated. It's not just, oh, my bulb is out. Let's just check the resistance. Let's just check power and ground. It gets a little more complicated once we get to these HIDs. And then maybe even a little more complicated when we get to the LEDs. So LEDs stand for light emitting diodes. They have a lot of benefits, though, over any other lighting source. They're a lot longer lasting. They'll last for many, many more on and off cycles. They draw far less power, so we can actually use them on electric. That's usually what they use in electric vehicles, hybrid vehicles now too. They've gotten to the point where the brightness of the LED is now better than an HID bulb brightness. So they're actually brighter than an HID bulb. So the brightest thing going, and that's pretty much if you were driving down the road at night nowadays, it's almost hard to see. Does allow manufacturers, though, design flexibility. Because I remember when this Hyundai Tucson came out, they were making such a big deal about these lights here. And they're not even the headlights, they're the daytime running lights. The headlights are down here. But they have these fancy little LED daytime running lights there, which allows them this flexibility. Because how big is an LED? It's a teeny tiny little thing, couple millimeters in diameter. So you can put a lot of them in a small space, which allows them to be brighter. And it can also make them so they can look a little bit nicer. So we got the, in this case, this is that Hyundai daytime running light there. So we got our housing in the back, and then we have a reflector and LED assembly. So you can see there's a bunch of LED bulbs in there, and there's a reflector source in there. Then we have an outer lens to protect it, a bracket, and then a garnish. So you see it's a 5-piece headlight system, but it's not, like I said, it's not even the headlights, it's the daytime running lights. But it looks cool, I guess. You know, designers want to go a little crazy with the designs. They can do that now because of this LED technology allows. And that brings us up to intelligent lighting. So we have vehicles now working with the ADAS and stuff, where it'll turn the lights. If I'm turning to right, it'll turn the lights right. If I turn to left, turn the lights left. It'll can go up and down. Based on the weight distribution in the car, it can automatically move them up and down as well. Move them up, down, and all around. There's some even newer technology on the LEDs, which we're going to talk about in a little bit, where they actually use individual pixels. And they can dim the individual LEDs to make it so it doesn't blind oncoming drivers with their high beams. So many modern vehicles, like we said, use computers to control the lighting. Examples include automatic headlights. So it'll turn on your high beams automatically and dim them automatically. Automatic beam switching would be that. Automatic headlights when they turn on after dark. Headlamp leveling. So like I said, based on the suspension, based on how the vehicle is leaning, how the vehicle is loaded, it'll bring them down if it needs to, or bring them up if it needs to. Directional headlamps. So I turn left, they go left. Turn right, they go right. Advanced front lighting, where it can actually adapt the beam backwards and forwards and move it around. It's kind of nuts. And then adaptive high beams as well. Like I said, the dims individual LEDs and individual portions of the light in order to make it so you don't blind oncoming drivers, but you can still have high beams on the other side of the road. Kind of a nice in between. So different manufacturers will use a variety of sensors in order to do that. They'll use the front view camera so they can see oncoming traffic. Oh, there's a car there, and I can see the headlights, so we can dim the lights. Sun load sensor on some cars. So if the sun's not out, the sun goes down, then we can turn on the low beams. Rain and light sensors, same thing. If it's got raining, it'll turn on the lights. If your wipers go on, it'll turn on the lights. Just a light sensor in general for ambient light, it'll turn them on if there's a lack of ambient light. Also use actuator motors to rotate the lights and move them up and down. And then position sensors as well. I need to know my height of the vehicle, suspension position sensors, steering angle sensors can be used for that as well. So if we know if we're turning right or left, it's kind of funny to think about with this, but that's way back in the day. The Tucker. had that. There was plenty of other cars that had it too, along the way. But the Tucker was probably one of the more famous ones because they made the movie about the guy. But the center bulb in the Tucker would move back and forth too. That was more of a linkage. But now we use actuator motors and sensors to do that too. So we would test the motors, test the sensor. Here's an example on a 2019 Cadillac ATS as to how things have changed. So this is the left headlamp assembly. That's the right headlamp assembly. You'll notice there's only 3 wires going in and out of these headlamps. I got power on the red line. I got ground on the black line. And then on this green and violet line, well, that is network connection. So it operates it all over the network bus. So it sends network messages to the headlights. They have little logic boards inside them that will turn them on and off. And also they have a leveling actuator and a horizontal motor. So we have vertical motor and a horizontal motor. So to test these, internally, you're probably not going to be fixing much, probably not going to be changing much. But you'll be checking for power and ground, and you also want to make sure that network is working. So you're going to have to get into network diagnostics a little bit on this. So I think that's kind of interesting that how we've gotten to that point. Notice how we also have the left front suspension position sensor on there, so it knows where the suspension is, height-wise. There's a 2019 Mercedes E450. We're going to look at this a little bit deeper. So that's got the LED headlights I talked about earlier, and it has the technology where it uses a matrix of LEDs, and it can auto dim the high beams. So when a opposing vehicle is coming down the road, it'll dim some of the LEDs where it needs to in order to dim that. So we can actually see we have adaptive high beams right here. We have a whole bunch of connectors going on there. This is the left front LED matrix lamp control unit. So we got all these LEDs hooked up, and we got the signal lights actuation. We have a fan motor because the LEDs can run a little hot. So we got fans in these now. We got our low beams. We got our adaptive high beams in there. Multiple matrices of beams. And if we go down here, we have our position lights, cornering lights, left LED driving lights, actuation module, fan motors. We got our fan motors there. Level sensor for without body control, air body control, left rear level sensor. So we have our leveling sensors because it can adapt the beams to that too. So it'll rotate the beams left or right. So there's a lot of different things you may need to test if you're going in and checking on these systems. I got motors, I got sensors. It might be a suspension sensor that messes up my headlight system because they're all interconnected and tied together now. Now here's an even more interesting. Laser lights. Laser lights. A couple of manufacturers use this. BMW's seems to be pretty well on board with this. They use it in quite a few models of late model BMW. It uses a laser to generate a beam. That beam then bounces off mirrors inside the assembly, reflector assembly, and it bounces it, focuses it onto a yellow phosphorus lens. So the lens is coated with this yellow phosphorus. When the yellow phosphorus gets hit with the laser, it generates a brilliant white light. But due to the way that they can shape the beam and move things around because it's a laser, that makes the beam forming very highly adaptable to opposing traffic. So if we take a look at this little video that I found, we got a car coming. It's able to actually warp the beam, move it further and closer down the road, then moves it out of the way, and then it moves it back where it needs to go. So it's actually able to adapt to that oncoming traffic. And I think that's kind of cool how we're able to do that. I'll play that one more time. So we get a car coming, opposing car, warps the beam around it, gets to the point where it just kind of closes the beam off, sets it to the right-hand side, and then brings it back to where in the middle as we're driving down the road. So I think that's a pretty cool tech. I'm sure it's not, actually, I know it's not cheap. So we're going to actually look and see how much one of those headlights cost in a minute. But cool technology. Maybe it'll come down in price. Probably will. Hey, maybe we'll have tons of cars around with laser beams driving around. Cars with laser beams. Crazy, crazy stuff. All right. So let's go to some vehicle examples. That one last, though. So let's see. HID lights first. We'll go with this Genesis. It's got the projector beams. Oh, actually, wait, hold on. Before I do that, if you want to learn more about lighting systems and you have a snap-on scan tool with a guided component test in there, so Zeus, Zeus Plus, Varus, Verdict, Vantage, Modus, Triton, any of the tools with the scope, it's going to have the guided component tests. And then when I go in there, I'm going to have classes built in as well. So we go into classes and we go under how to. We can see there is, let's see, 10-minute high-intensity discharge lighting class. So we got HID bulbs going to tell us how it works. So it's an optional extra on many models. It may also be a standard fitment on top of the range model. System replaces the standard filament bulb used for dip beam operation with specially designed. This bulb contains 2 electrodes approximately 4 millimeters apart and a quartz bulb containing mercury, metal salts, and xenon under pressure. So here's our bulb right there. The advantage of this, due to the absence of a conventional filament, the lifetime of the bulb is greatly increased. So we don't have to worry about the filament burning out like a conventional halogen bulb. It can be as much as 4 times greater. Driver will have a wider field of vision and greater illumination during the hours of darkness, and it allows 2.5 times the light flux at approximately half the temperature. Light flux is the flow of energy from the bulb in the form of light. Due to the intensity of the light, provisions have to be made to ensure that other road users are not dazzled by the headlights. A system must be in place to automatically adjust the headlight level under transient conditions such as cornering or when the vehicle has a load. So the lateral acceleration sensor will relay the vehicle dynamic characteristics during cornering to the electronic stability control. Signals then put on the CAN bus where the HID control module can access the information and then it can move it up and down, or it uses suspension height sensors on the suspension. Also need to have a headlamp washer system to be able to clean the headlights. It's to ensure the lamps stay clean and there's no debris on the lens. Headlamp washers will be actuated when the dip beam is switched on and the windscreen washer switch is activated. So the ballast igniter is used to create a high voltage arc, as we said. Current reacts with the xenon, which emits light, and then the temperature rises. Mercury and metal salts vaporize, increases the pressure in the bulb. Light turns from blue to white. Ballast system limits the current and voltage to the bulb, increases the life of the bulb. So you may have noticed when you watch a HID bulb turn on, you'll see like a quick spark, and then it kind of turns a little like a blue dim. And then as it warms up, you'll see it turn sort of white. It doesn't take that long, but it is noticeable the color change from the blue to the white as well. And then it's just going to rate up 35 watts, continuous light, no flickering. Flickering will be bad. All right, so that's HIDs, and then there's also a class in here on priority lighting. Now, we didn't really get into this, but priority lighting is a new safety feature made possible by the use of CAN bus. An exterior lighting module can monitor the current flow through each bulb, and if a fault is detected, another bulb in the cluster can be used. So if I have multiple bulbs doing multiple things, for example, using the rear lights as an example, a manufacturer can fit bulbs of the same wattage to the lamp cluster. As opposed to using additional bulbs that will lower output, this makes it possible to use another bulb in the event of a bulb failure. Warning light on the instrument panel will alert the driver to the malfunction. All right, we can see how it is a frequency, duty cycle. All right. That's our classes. Now let's go into this Genesis. And take a look. We actually have got a component test for some vehicles on this. Underbody electrical. And then exterior lighting. Pardon me. HID headlights. Component information. So this vehicle is equipped with a set of HID headlamps. These headlamps are much brighter and last longer than conventional filament type headlamps equipped to most vehicles. A brief explanation of how it works, which we just went through. And then there's a 14-pin connector at the headlamp. So we have a couple grounds. Low and high control, solenoid control, on and start, arcing lamp control, ground. This vehicle is equipped with HIDs. They implement a ballast igniter, which increases the vehicle's battery voltage to a high voltage in the region of 20,000 volts. Caution should be taken while diagnosing these headlights, and testing should only take place on the battery voltage portion of the headlights. This portion is the wiring harness traveling to the ballast igniter and back. Never should one test the high voltage exiting the ballast igniter. Always follow the manufacturer's recommendations and warnings. Failure to follow safety warnings can lead to injury or fatality, so don't mess around. So we could do a DC voltage test. And we can check on the fuse and relay, polarity of the ballast, bulb connector, condition of the bulb. And then should be over 9 volts available on the input side. So on the low control, and then we see a volt. So that's one. Let's see what the wiring diagram looks like. All right, so we got some testing, location, removal and replacement info. This is where I got the pictures of the. There's the ballast. There's the bulb. Let's see how we can take that apart. Component operations, where I got the pictures of the projector beam. So you got the little solenoid. The high beam is going to tell us how it works. LED headlamp is going to have a just a kind of an LED module that you'd have to replace. And really, if one goes out, you got to kind of replace them all. I'm sure there'll be a market out there at some point for people to actually like resolder the boards, probably, but I haven't really heard of anybody yet doing that. To adjust the and aim the headlight, we're still doing a mechanical aiming. We still have a couple screwdrivers here, horizontal and vertical aiming. It's going to give you your aiming points and all that good stuff, just like you do a normal halogen bulb. And then parts and labor, let's see how much. So you have to remove the front bumper cover to take it off. So must have some bolts behind the bumper. And then the headlight is $1,700 at list. So that's a good amount. See what we got for information on the scanner on this car. Go down to lighting. We have adaptive front lighting down here. And let's see, we're going to have codes and data. Oh, system tests. We got a calibration mode. Come in here and calibrate it. So engine off, ignition on, empty vehicle. It's going to, it might give me an error here. Yeah, front and rear sensor out of limits. But we can do a calibration. We can also do a parameter download, which is kind of like an as-built type thing. So I go in here and I'll go through the different parameters on the car. Since we're not hooked up to a car, doesn't really do anything here. But parking out flat, vehicle speed less than 5 kilometers an hour, no gear position change, diagnostic connector, etc. So is it left-hand drive or right-hand drive? It's automatic or manual. I have air suspension or not. HID lights or LED lights. The 2-wheel drive or 4-wheel drive. You just go through it and pick the different things. Where's my region? Is it dual or quad? Go there. Is it a sedan, hatchback, or wagon? Or long body? We'll just try sedan. And then the test will fail because I'm not hooked up to a car. But you could go through there with the parameter downloaded. You can actually punch in like the vehicle order and reinitialize the light if you want to. That's kind of cool. Next one, let's go to the adaptive lighting on the Lexus. And on this one, it's going to have a little bit different in the wiring diagram. Go. So it's got a lot more repairs on this one. Component operation, I think it just kind of tells you how it works. Yeah, no pictures. Wiring diagrams again. Headlights, and then we can see we got a across the way here. We got our 2 headlights. Those have some motors in them. So this one's going to be kind of standard. So it's got a cooling fan in there. It's got a leveling motor in there. So you got a whole sub-assembly right there all together for leveling on the headlights. Doesn't really have much else for that. And then as far as resets, relearns, calibrations, tells you how to initialize it using the scan tool. And then as far as how much it costs, that's $2,900 on those because they're a little bit fancier, I guess. See what we can do on the scan tool. Okay, so we got to come down here, down to our lighting. Got our adaptive front lighting and automatic high beams here. Let's see, system tests. What do we got? We got a lot of different system tests in here. So there's a adaptive lighting here. We have different patterns that'll go through, different functions on and off. This is a residential mode, so it goes one way. Low beam range adjustment, low speed wildlife function, rain dim function. So it's got all sorts of different functions you can turn and go in here and function on and off to make sure that it's working. Shade angle settings, so that's for your high beams and low beams on there as well. So a lot of different actuator functions you can do inside there to test the different functions of the headlight. Now, if it's not working, probably going to just replace the headlight for $2,900. But you can see what's wrong with it and test, and maybe it's not actually a problem in the headlight. Maybe it's a problem somewhere else. Okay, let's do the LED lights on the Mercedes. Same thing, headlight. Got some TSBs on this too. Headlamps fog, multi-beam LED headlamps. You might have a fault message in the instrument cluster. That's due to the LED needing to be reprogrammed, actually. So the monitoring by the LED headlamp control unit may be too stringent, so it'll set this fault code, and then you would actually have to give it a reflash in order to fix that problem. Wiring diagrams. I'm going to do our headlights, and then that'll bring us back to our headlights we saw earlier, the LEDs. Right there. So there's our LED arrays, and we have our multiple dimmers for our adaptive headlights. As far as scanner functions on this, I remember which module it's in. Wow. So we got our left and right headlamp modules. So LED matrix module, you can actually go in and turn on and off some of these matrices. That's that one. So special functions, we can do a self-test in a matrix system. And as far as actuator tests, we can do the light distribution and the fan motor. So the light distribution is going to change between the different low beams, high beams, and motorway beams. So it'll change the on and off of the LEDs there. That one. And then always on a Mercedes, you want to back out the proper way. Augmented reality camera. And then the last thing, we'll look at the BMW, the laser lights. So there's not a ton of information out there right now on it. But, oh, I got to log myself out here. Logged in a bunch of times. Right, headlight. Hey, we see there's TSBs on that too. High beam headlight failure, daytime running lamp is dim or discolored. I think it was, that's the one that's got the, it's different. That's something different. There's one that had a light. Maybe it was this recall. Yeah, recall. So they'll have discolored lights in here that could happen. So you can see where it's blue there. It's not supposed to be blue. It's supposed to be more of this white color on the outside of the light. So that's a problem. It needs to be replaced. There's just a closer look at that, what it's supposed to look like in there. So there's a recall on that. And you just replace it. How about parts though? How much is a laser headlight? On this thing is $6,300. $6,300. I'd want to be very, very sure that it's broken, and it takes about 4 hours to replace it. So I'd want to be very, very certain that was indeed broken before I went and changed. As far as scan tool functions, there is some stuff in here. Lighting. We got high beam assistant, light effect manager, and then our headlight electronics. So on this one, I have to pick something there. Special functions we can teach in the turn signal. As far as actuator tests, high beams, low beams, daytime running lights, and such, we can turn them on and off to make sure that they're working properly. Other than that, it's powers and grounds and switches and solenoids, because a lot of them are self-contained, so you're not really going to be pulling them apart. You're not going to be switching things out. When an LED bulb goes, it's going to go, and then you're probably going to need to replace it. So, but as far as diagnosing it properly, making sure you're not misdiagnosing a $6,000 headlight, that's definitely something I would not. I would want to make sure, 100% sure that it's definitely the headlight before I go and order that. Sure. All right, that is this week. It's my time for advanced lighting systems. Kind of some crazy stuff out there. Let's talk about a sweepstakes for the US and Canada, North America. If you're watching elsewhere in the world, I'm not sure if they're doing any other sweepstakes, but as far as the US and Canada, we are giving away this epic Zeus Plus workstation. So anyone, all of y'all, as long as you have a Snap-on scan tool that can be updated to the current software version, which is 22.4, as long as it's running 22.4 by the end of the year, December 31st, 2022, you will be entered to win this unique custom wrapped personalized design. It's even got to have your name on it if you win. So this is $24,000 at retail, because it's a 36-inch Epic with a riser, and it also has the Zeus Plus inside with a dock with a 27-inch touchscreen on the back wall to be able to cycle through that. So that is really a really cool prize, I think. And all you got to do is just make sure your tool's updated. If you're already on software subscription, just update it. If you're already on a prepaid plan, just do your update. If you did the buy one, get one free, install your free update. You can do it yourself. You can have your Snap-on franchisee do it as well. But as long as it's running the software, by the end of business on December 31st, we're going to do a drawing a few days later. And if you had it on there by then, and you're going to get entered to a drawing. One per region, so we're giving away 10 of these. There's 10 regions in the U.S. between the U.S. and Canada, so you may have a pretty good chance to win. Okay, so next week, we're going to be talking about charging and starting systems. So I'm surprised it's taken us this long to get this far to talking about this, but we're talking about alternators, starters, some of the newer technology we got going on with alternators, with the overrunning clutches, with the starters, with the start-stop system. Talk about all of that stuff. So same time, same place next week, 6 and 9 Eastern. If you want to go to snapon.com/OT, you can join me on Zoom. The 6 p.m. class goes to YouTube, youtube.com/snapon-diagnostics. If you're watching on YouTube, we'd definitely appreciate it if you give us a subscribe and a like, and ring the bell and all that good stuff, because it really helps us out create more of this content for you. 9 p.m. Eastern goes to my Facebook page as well, so you can look me up on Facebook. If you're interested in any of the other prior classes we have done in this series, so anything from ADAS, data bus testing, component testing, VVT operation, etc. Any of these classes are available archived on YouTube, so youtube.com/snapon-diagnostics. Once again, there is a playlist for live training readily available. Now it's time for Q&A. If you got any questions, if you joined late on Zoom, just look at the top or the bottom of your screen, wherever your Zoom controls are. You should see a Q&A button. Type in your question there. On YouTube, I see we got a few comments in there. Just if you have a question or a comment, use the live chat. Before I do that, though, I want to make sure I remind you about my buddy Al, who does diagnostic scan tool specific training. So on Mondays it's on Apollo, Wednesdays it's on Zeus, and Thursdays it's on Triton. Same time, same place though, 5 and 8 Central. If you go to snapon.com/OT, you can register to sign up there. Very thorough class. Apollo class is about an hour. Goes through a lot of the buttonology, and here's how to navigate through the tool. Zeus and Triton are about 2 hours long, because after that first hour, takes a small break, and then he goes through another hour with the scope and meter function. So this is very thorough. class. Al's been with us for over 30 years, so definitely worth your time. Go check him out. All right, Q&A. Not seeing anything on Zoom. That's okay. So let's see. Abel, welcome. Hello. Mike Regina, hello. Patriotic Immigrant. I don't know if you came back. You said you'd come back. Corvette Rick, hello from Alaska. Welcome. Nick, welcome back from the UK. Quinn, welcome from Mooresville, North Carolina. Good to see you. Let's see. Nick says, can't wait till next week's class. Thank you very much. Let's see. Brian Lamontagne, is there any way to check the igniter for the headlights? So really all you're going to be able to check is the input side. Just because you don't want to deal with that high voltage on the output side. Now you can deal with the input side. Output side, I suppose you could do if the manufacturer has a spec for resistance. That might be a way to go. You just want to make sure it's disconnected from the vehicle for a long time. And you want to make sure maybe even you give the time for the capacitor. I'm sure there's capacitors in there that need to discharge and such. So you want to make sure you're dealing with very high voltage. You just don't want to get it. So I would say that'd probably be your two best ways. Some manufacturers might actually have a way to test it. We don't really recommend dealing with that high voltage on the other side. You got power coming in. Hopefully you got power coming out. And if you don't, then maybe there's an opening or a short side there. Hopefully that answers your question there, Brian. And with that, I think that kind of brings us current on our questions and comments. So I'd like to thank everybody for taking a little bit of time out of your busy week to come and spend a little bit of time with me. Hopefully you'll learn a little bit more about some of that new technology with the lighting systems that are out there nowadays, and can take that out and know that your scan tool will help you out with that as well. With that, enjoy the rest of your week. Hopefully we'll see you next week for starting and charging systems. Enjoy the rest of your week. Enjoy your weekend. Have a good night. Take care.